Here's an example with a square root. So if we look at this, right, so now it's an algebraic function because it's got the square root, but essentially we can kind of do it exactly the same way. I do want to point out, I took the limit here first to infinity. We'll also do the limit to negative infinity, which is okay here. If I look what's underneath the square root, it's always positive underneath the square root. So that's not a problem, right? But you do have to be aware of these things, right? If there were some negatives in there or some weird stuff, I'd have to be careful. But the domain of this function is going to be all reals except for where the bottom is 0, so that we're going to have some asymptote at -8/7. But we don't care about that right now. We're only interested in the long time behavior. We're only interested in the x going to infinity. So as I said, I'm going to do the same thing. Okay, I'm going to divide top and bottom by the highest power. When you have roots, square roots, cube roots, whatever they are, you have to be a little bit careful about this, because in the bottom, of course, my highest power is just 1 because it's x, but in the top, my highest power, it looks like it's x squared, but I'm taking the square root of x squared, so it's still x. So the highest power is x. Let me just write that down. So you can look at the highest power under the root and then take the root of it, right? And that will give you the highest power in the top. And of course, it turns out that the top and the bottom, they have the same. So what I want to do is divide top and bottom by 1/x. Now, in this case, I'm going to write it out a little bit clearer just so that we all remember what we're doing, right? Because it's got the square root. So I have to take the x, 1/x inside the square root, right? What I'm really doing then is I'm writing x as this, right? The square root of x squared. So, let me just write something. So I've got 7x plus 8 here, just divided by x like usual, but then I've got 4x squared plus 16. I need the whole thing under the square root, so I can think about this as dividing by square root of x squared, right? And then that whole thing goes under the square root. So this just becomes this. And then I have the whole thing under the square root. And I end up with this. Okay? So you have to be a little bit careful. That's why I did it in an extra step. Now, however, I'm fine to take the limit through, because everything here is going to be positive as I go out to infinity, right? Everything here is actually going to even be finite. I can pull the limit under the square root because the square root's continuous function. So basically I'll write it once, again, with the limit as x goes to infinity of 4 plus 16 over x squared underneath the square root, and then I just have the limit as x goes to infinity here, 7 plus 8 over x. But you can see again, when I've got the 8 over x, that's going to 0. I got the 16 over x squared, that's going to 0. The 4 and the 7 are the same, but I've got the square root, so I've got square root of 4 over 7. So my answer is 2/7. Okay. So that was interesting and fine. I know that for this function, as I'm going out to positive infinity, I'm going to be getting an asymptote of 2/7. Now let's though talk about what happens when I'm going out to negative infinity. Okay? Let me erase this. are still going to be x because I'm still talking about the square root of x squared. Fine. But now, look what we did though. In the second step, you have to be careful or you'll lose the minus. Okay? What we did is we wrote in the previous thing, we wrote this as x equals the square root of x squared. Okay, that's fine if x is positive, which it was last time because we were going out to infinity. But this time, x is negative because we're going to negative infinity. So this is not correct, right? Because when we take the square root, we're automatically taking the positive square root of the number. That's how we set up square root so that it's a function. So this is not the case here. This is not true if x is negative. So that's the kicker here. That's the little trick that will get you the wrong answer because you'll lose your negative. If x is negative, we need x to be the negative square root of x squared. Okay, so that when I write the second step, that I wrote specifically so that we could see what was going on. I wrote it as a square root of x squared, so we see that we're getting under the square root, but you've got to have a negative there because I'm talking about negative x's. Okay? Now you have to be, okay, we can actually sort of think about this from a graphical standpoint. If I just look at my original function, right, and I just think about the sign, if x is negative, if x is very large and negative, the top is still going to be positive, but this bottom is going to be negative, right, for any x, you know, on that side of the negative 8/7, right? So for any x less than negative 8/7, the bottom is going to be negative, so all of the values are going to be negative. Now when I multiply by this, in this form, it doesn't matter if x is negative or positive because I'm multiplying by 1. It's the same thing on the top and the bottom, so the negative will cancel out. The reason it doesn't, you have to put it in explicitly, is because of the square root, okay? And that would be true if it was any even power, like it was an even root, like the 4th root, the 6th root. The cube root, it doesn't matter for the cube root because the cube root is defined with the negative, plus, negative, whatever. You know, so if it's an odd root, it's okay. You don't have to do this. But if it's an even root, so it's a special case. It's a case that they like to do because it's a little nitpicky point. But you have to put that in specifically. Now the rest of the thing goes exactly the way it did in the previous example. This becomes 7 plus 8 over x. There's a negative in front here. This becomes 4 plus 16 over x squared. And then as I take x to negative infinity, that goes to 0, that goes to 0 as well. And I end up with a negative 2/7 this time. Yeah, so there it is. So this is one thing you do have to be careful with those square roots.